Section 4.2, example 3, says on page 252, we have recall that the FOIL method of multiplying binomials uses the distributive property to multiply each term of the first binomial by each term of the second binomial. You can extend this method to use the distributive property to multiply any two polynomials. Now, the book does this using what they call the distributive property, and then they don't really show you what they did. So I'm not a huge fan of that. I don't like FOIL. I don't like when they say they use the distributive property and then don't show you any steps. So I like the box method, like I taught you guys with factoring. Fun fact, it works both ways. So we can use it to multiply polynomials, and it's actually pretty easy to visualize. All you have to do is make a box that has however many terms you have on one side and however many terms you have on the other side. So here we've got 2 and 2. So notice I put 2 up top, 2 on the side. Here I have 2 and 3. So I made 2 and 3. It doesn't matter which way they go, just as long as you have a side that has 2 and a side that has 3. So this works for any two polynomials. You can only do 2 at a time. So if you notice down here we have 3, I have 2 boxes because we're gonna have to do it twice. So all you have to do is write each term above its own box. So 2x and 3y go together. I'll put them on top. And then I have 7x and negative 4y. This is just like Battleship. So if you've ever played Battleship and you were like B4, and then you went over to B and down 4, you'd hit the spot, and then you decide whether or not you had a little ship there on the opponent's team. So same idea, or just like Punnett squares in biology. Here I have 2x, here I have 7x. I'm going to multiply those two together, and that will give me this box here. So 2 times 7 gives me 14. X times x is x squared. Same idea, 7x times 3y. 7 times 3 gives me 21. X times y is just xy. So if they're not the same variable, you don't put squared, you just write them next to each other. 2x times negative 4y gives me negative 8xy. Negative 4y times 3y gives me negative 12, and y times y gives me y squared. All right, now you can do this while you're still in the box, or you can write it all out. So I'll show you both. You can write it all out. So notice I had a positive 14x squared, a positive 21xy, a negative 8xy, and a negative 12y squared. However, I have some like terms. So notice that these two right here both have xy. Here I have a y squared, here I have an x squared. I can't combine those with anything, but these two are both xy's. So 21 minus 8 I can combine to get 13xy minus 12y squared. So that is our final answer. Now, I didn't have to do this step right here. I didn't have to rewrite them all, because if we look at the box, you can see I have a 21xy and I have a negative 8xy. I can combine those before I write anything out. So I could say, okay, I'm going to start with my 14x squared. 21xy and negative 8xy gives me 13xy, and then I have negative 12y. So I can skip this step if I really want to. Same idea with this box. Clearly I have to put my x minus 5 on the 2 spot, and then my 4x squared plus 9x minus 1 has to go up top. I could have made it 3 on this side and 2 on this side. That doesn't matter. One thing I do want to point out is when I took each piece out over here, you have to keep the same sign. So here we had a positive 14, so that was positive, positive 21, plus, negative 8, minus, and so on. Now, in our new box, we're going to do the exact same thing. So 4x squared times x gives us 4x cubed. X times 9x is 9x squared. X times a negative 1 is negative x. 4x squared times negative 5 gives me negative 20x squared. Negative 5 times 9x gives me negative 45x. Negative 5 times negative 1 gives me positive 5. Now I'm going to skip the step of writing everything out, and I'm just going to look for like terms. I've got a negative 20x and a positive 9x squared. Sorry, those are both squared. I have negative 45x and negative x, and that's it. My 4x cubed is by itself, and my constant is by itself. So now I can just go ahead and write my final answer out. So we have 4x cubed, negative 20x squared plus 9x squared gives us negative 11x squared. Negative 45x minus x gives us negative 46x, and then plus 5. So altogether, that gives us 4x cubed minus 11x squared minus 46x plus 5. So notice that here we have a c and a constant, here we have a c and a constant as well, here we have c squared and a constant. If you pick the ones that have things in common, you'll end up with less different terms. So c and a constant, those will give me more like terms than if I were to use c squared plus 2. So I'm going to save c squared plus 2 for the end. So I highlighted the two I started with, c minus 3, 2c plus 1. If I do 2c times c, I get 2c squared. If I do 2c times negative 3, I get negative 6c. If I do c times 1, I get c. And 1 times negative 3 gives me negative 3. Now if I check, I've got some like terms. I have a negative 6c and a positive c. If I had used my c squared plus 2 and one of these, I wouldn't have had like terms and I would have needed a 2 by 4 square. So it's not impossible, it would just be a little bit more work. So I'm going to rewrite the inside pieces as the new green portion of my expression. So we have 2c squared, negative 6c plus c gives us negative 5c, and then we have minus 3. So again, this new piece right here is equal to these two being multiplied. So this is going to be replaced by this. So now our new goal is to multiply c squared plus 2 times 2c squared minus 5c minus 3. So I'm going to fill that in on this 2 by 3. So over here we have 2c squared times c squared, that's 2, and then I have 4c, so c to the 4th. 2c squared times 2 gives us 4c squared. Negative 5c times c squared, that's negative 5, and then we have 3c, so negative 5c cubed. Negative 5c times 2 gives us negative 10c. C squared times negative 3 is negative 3c squared. 2 times negative 3 gives us negative 6. So now take a look, see if you can find anything that they have in common. I see a 4c squared and a negative 3c squared. I can combine those, and then all the other exponents are different. I have a 4, a 3, a 1, and a 0. So when we write this out, we get 2c to the 4th minus 5c cubed, and then I had my negative 3c squared plus 4c squared gives me just c squared, so positive c squared, minus 10c minus 6. So this would be the complete final answer to this original part C, 2c to the 4th minus 5c cubed plus c squared minus 10c minus 6. And I highlighted that just so you could see that those were the two that got combined. So to do 3 pieces, you just make 2 different boxes. I recommend doing your first box and then drawing your second box, because if we had done it a different way, we would have needed 4 up top. Now, when I told you guys I don't like when they say distributive or FOIL, that's because this is all they do. They say, here's your problem, FOIL it out. Oh, magically, here are all the answers, and then they combine like terms. So they do show you the one step of combining those like terms, but that's all they show. Same thing with part B. They're like, oh, distributive property. Cool. They show you how to break the first part apart, but then they don't actually show you any of these steps. They're just like, okay, we distributed a bunch and then combined like terms. Part C, same idea. They say multiply. So they didn't even mention that they did the FOIL method, and then they distribute, and then you're just distributing a whole bunch and combining like terms. There's no visual here. It's a lot of mystery if you ask me. So I really like the boxes. If you like distributing and FOIL and you're good at keeping track, go for it. The box is really just a visual way of distributing. So now I would like you to find the product of x minus 6 times x plus 2.